Hello all, in this tutorial we'll be discussing about octal to binary encoder. That is, as in the previous tutorial we have seen the format for encoder is 2 power n to n, that is 2 power n is the input and n is my output. So correspondingly if I have 8, that is 8 is nothing but 2 power 3, so that means I have 8 inputs. The inputs are I0 to I7, that are my 8 inputs, and you can see as n is 3, so I'll be having 3 outputs. So this is 8 to 3 encoder block diagram. Like what will be the inputs and corresponding outputs, it's been shown in the following table. That is same as what we have done in 4 to 2 encoder. That is, I will be drawing 8 inputs, 3 outputs. First MSB I will be making it as 1, followed all the rest inputs to be 0, and that 1 I will be keep shifting based on the suffix. Say for 0 I0, it will be a starting position will be 1, that is MSB is 1, and MSB is shifted by 1 from the right bit. As you can see, it is 0 1, then again this one is shifted over here, this one is shifted over here, here, and finally I7 over here. Based on the suffix, the output is correspondingly made as 0. For 1 it is 0 0 1, for 2 it is 0 1 0, for 3 it is 0 1 1, for 4 it is 1 0 0, for 5 it is 1 0 1, for 6 it is 1 1 0, and for 7 it is 1 1 1. Inputs and the output combination in the truth table. Now let us quickly analyze what is y2 then. Y2 is nothing but equals to, as you can see, y2 is I4, I5, I6 and I7. So I'll just use an OR gate for I4, I5, I6 and I7. I'll connect with an OR gate to get it for Y2. Similarly for Y1, if you see, it is 2, 3, that is in OR gate for I2, I3, I2, I3, and then I6 and I7. So I6 and I7, I'll be just using an OR gate. And similarly for Y0, as you can see, one over here, one is in this case, another one is in this case, and another one is in this case, and the final one is in this case. So I'll be writing it as form of I1, I3, I5 and I7 using an OR gate. OR means simple, I will be just adding the equation. So if I draw the circuit diagram for it, it will be something like this. So as I have having the output for y2, so y2 is nothing but I4, I5, I6 and I7. What about y1? It is I2, I3, I6, I7. This is y1 having the input, say this is I7, this is I6, I6, I7, I2, I3. So this is say I3 and this is your I2. So this is corresponding to Y1. And what about Y0? Y0 is I1, I3, I5 and I7. So what I will be doing is, and the corresponding input should be something like this. Say this is I1, say this is I1, this is another is I3. So I3 I will just use the input from here and sort it over here. This is I3. Next one is I5 and I7. So as you can see, y2 is nothing but I4 plus I5 plus I6 plus I7. Y1 is nothing but, as you can see, the input is, this is I6, this is I7. So I'll be writing it as I2 plus I3 plus I6 plus I7. And for Y0, it is I1, this is I3, this is your I5 and this is your I7. So I1 plus I3 plus I5 plus I7. So this is the way how we represented the output, and this is the circuit diagram for the corresponding truth table that we have drawn. The main drawback of the encoder is, what if you say the inputs you have provided, say I0 and I1, that is in the given combination of inputs, if two ones are there, say I0 and I1, I have something, the case of input like this. Now you will be confused, or the circuit will be confused, whether I need to give the priority to this one or the second one. That means either the output should be 0 0 0 or 0 0 1, because as you can see, one, the corresponding one MSB, my output is this, and for one the output is this. So in order to overcome this issue, the concept of priority encoder took place. So priority encoder, what it says, it gives priority to whatever one comes in the MSB. That is, say suppose if the value is 1 and taking the priority, so my output will be nothing but 0 0 0. That means I need to again draw a table. That modification I will be drawing over here itself. So the table would be something like this. So the priority encoder, what it does is, if MSB is 1, that means from going from left to right, if I get any bit to be 1, and irrespective of other remaining bit, that is either it is 1 or 0, my output will follow corresponding to this bit. Similarly, for this case, if it is 0 and 1, that means the first bit need to be 0. As I can see the MSB, that is in the second bit, so corresponding output will be this. For the third bit, if I can see there are 2 zeros and 1, then my output will be this. So this is how the priority encoder helps to overcome the issue of encoder. For example, I have say the case of something 1, say it is 0 0 1 1 0 0 1 0. See, in this how many bits are ones? 3. But as I will be moving from left to right, the first one is coming in the third bit. So the third bit output will be nothing but 0 1 0. Whether it is 1 in the fourth bit or fifth bit or sixth or seventh or eighth, after coming from left to right in which bit it is the output is 1, that will be my the output. In this case, as you can see, it is in the second bit, so my output will be 0 1 0. This will be my required output. Hope this tutorial is clear to you all. Thank you.